All right, for any pilot, reading a METAR is a must-know skill. But let's be real, staring at a fresh one for the first time can feel like you're trying to crack a secret code. Well, in this explainer, we're going to do exactly that. We're going to dive in and crack this thing together.
You see this string of letters and numbers, and somehow it's supposed to give you a perfect picture of the weather at an airport. I know, it looks incredibly complex, but I promise you, there is a clear, logical structure hidden in there.
So, how do we get from that jumble of code to a clear mental picture? Well, for this explainer, we're going to use this fully loaded METAR from Toronto Pearson International as our guide. This thing is just about every element you might run into, which makes it the perfect example to break down.
So, first things first, what is a METAR? It stands for Aerodrome Routine Meteorological Report. But really, all you need to know is that it's an hourly snapshot. It's the weather conditions on the ground at a specific airport at a given time. It's the most direct way to know what's happening right now where you plan to be.
Okay, let's start at the very beginning. Like any good message, a METAR first tells you what it is, where it's from, and when it was sent. This is the foundation for everything else that comes after.
So, taking a closer look at our Toronto METAR, we're going to start with this very first block of text. This section lays all the groundwork. It tells us the report type, the airport it's from, the time of the report, and if it's been corrected. The report will always start with one of two words, METAR or SPECI. METAR is your routine, scheduled, hourly report. But if the weather changes in a big way, let's say a thunderstorm suddenly rolls in between reports, they'll issue a SPECI. That's a special report, and it's basically an alert telling you, hey, pay attention, something important just changed.
Next up, you'll see CYZ. That's the four-letter ICAO station identifier. The C is for Canada. After that is 15-1800Z. That's the date and time. It means it was issued on the 15th of the month at 1800 hours. And that Z at the end? Super important. It stands for Zulu time, or UTC. It's always in UTC to make sure every pilot in the world is on the same page, no time zone confusion.
All right, next up are the core conditions. Now we're getting to the good stuff. This is the information that's going to directly impact your flight. The wind, the visibility, and what you can actually see down the runway.
So this next block in our example, it contains three absolutely critical pieces of data that we're going to break down one by one. You've got the wind, the prevailing visibility, and then runway visual range, or RVR.
Let's decode the wind, 30015G25KT. The first three numbers, 30, tell you the wind is coming from 300 degrees relative to true north. The next two numbers, 15, that's the sustained speed, 15 knots. Then you see that G, that tells you it's gusting, in this case up to 25 knots. It's a pretty simple pattern once you see it.
Right after the wind, you see 3/4 SM. This is the prevailing visibility, and the SM means it's in statute miles. So 3/4 of a statute mile. Now, a number like that tells us something instantly. We are flying in instrument flight rules, or IFR conditions. Okay, now for something a bit more specific. RVR, runway visual range. This code only pops up when visibility is low. In our example, we have R23/4000 FT/D. The R23 identifies runway 23. The 4000 FT means the visual range is 4,000 feet. And that D at the end, that indicates the trend is downward, meaning visibility is getting worse. You might also see U for upward or N for no change.
And where's that super specific number come from?
Well, it's not just a person squinting down the runway. It's measured by high-tech equipment like this, a forward scatter sensor located right beside the runway. It gives a really precise, hyperlocal reading for that specific takeoff or landing environment.
Okay, so we know what the wind and visibility are doing on the ground. Now it's time to look up. This next section of the METAR paints a picture of what's actually happening in the sky above the airport. You know, rain, snow, fog, and of course, the clouds.
So let's focus on these next groups here. We've got SN, BSN, and then BKN 006, OVC 025. These describe two different things, the present weather and the sky condition. Looking at our example, SN, BLSN, we can decode it pretty easily. That minus sign at the beginning means light intensity. A plus sign would mean heavy, and no sign at all means moderate. SN is the code for snow, and BL stands for blowing. So put it together. We have light blowing snow at the airport.
Now for the clouds. Weather observers divide the sky into eighths, what they call octas. Think of it like a pizza with 8 slices. The codes tell you how many slices are covered. Our METAR shows BKN006 and OVC025. The numbers are the altitude in hundreds of feet. So this means we have a broken layer at 600 feet and an overcast layer at 2,500 feet.
And this brings us to a really critical concept for any pilot, the ceiling. The ceiling is defined as the first layer of clouds that is either broken or overcast. So in our Toronto METAR, that first broken layer is at 600 feet. That means our ceiling is 600 feet above the ground. And knowing that is absolutely vital for flight planning.
We're almost there. We're in the home stretch. The last main section of the METAR gives you the numbers you need for performance calculations and safety checks. We're talking temperature, dew point, and the all-important altimeter setting, plus any extra notes.
Okay, let's highlight the last few groups in the main body. Here we find the temperature and dew point, the altimeter setting, and the start of the remarks section, which you can see is indicated by that RMK. Breaking this down is simple. MO3/MO5. That M stands for minus. So the temperature is -3 degrees Celsius and the dew point is -5. Then you have A2992. That A is for altimeter. This is telling you to set your altimeter to 29.92 inches of mercury. And this is a non-negotiable safety step. It's what ensures you have the right altitude.
Finally, we have the remarks, or RMK. I like to call this the chatty part of the METAR. It's where the human observers can add important details that don't fit into the standard codes. You might find specifics on cloud types, visibility in a certain direction, or even sea level pressure. It is always worth a read.
So to recap the flow, it always follows a logical order. It's a story. First, you get the type, location, and time. Then the core conditions like wind and visibility. After that, what's in the air, the weather, and the clouds. And finally, you get the nitty-gritty details of temperature and pressure. Once you know this sequence, it's not a cryptic code anymore, it's a logical weather story.
And there you have it. You've just learned to translate the language of the sky. This skill opens up a real-time weather map of airports all around the globe. So the only question left is, where are you going to go first?